Siddharth this side. So welcome back to my channel and today we are here to discuss the solution of end semester examination. So here we start. So question number one. Explain how unstructured data is transformed into a format suitable for machine learning models. Summarize the importance of legal classification in the context of grievance redressal. How TF-IDF or word embeddings can be used to extract features from complaint text. Yes. So answer unstructured data. For example, unstructured data are in the form of text, images, audio, which is not in the form of tables. Lacks a predefined format to transform unstructured data into a format suitable for machine learning. So transformation of unstructured data for machine learning. So first point is text cleaning. Remove noise, that is eliminates unnecessary characters, example punctuations, special symbols. Lowercasing, convert text to lowercase to maintain uniformity. Stop word removal, exclude common words. Example is the that do not add value. Next is tokenization. Breaks down text into smaller units like words, phrases, or sentences. Stemming and lemmatization. Convert words to their base or root form. Example running to run. Now, transformation of unstructured data for machine learning. Next points are feature extraction. Bag of words, which is also known as BOW, represents text as a frequency distribution of words. TF-IDF, which is a matrix term frequency, inverse document frequency, assigns importance to words based on their frequency in a document compared to the corpus. Word embeddings, example, word to way, Glove converts words into dense numerical vectors capturing semantic meanings. Next is encoding, convert processed text into a numerical representation suitable for ML algorithm. Next is importance of legal classification in grievance redressal. Legal classification ensures efficient sorting of grievances into categories, example, labor issues, consumer disputes, etc. Next is identification of critical complaints requiring immediate attention. Standardized handling of cases, improving the speed and accuracy of resolutions. Enables analytics to identify trends in grievances for policy making. Next, feature extraction using TF-IDF and word embeddings. So TF-IDF, which stands for term frequency inverse document frequency. How it works? So firstly, we calculate how often a term appears in a document, that is TF, then weighs it against its frequency, its entire corpus, which is IDF, and usage. Highlight words that are significant to a particular grievance rather than common terms. Example for a grievance corpus, delayed salary payment. The word salary unique gets a higher weight than delayed common. Next is word embeddings. Why word embeddings? How it works? Converts words into dense vectors by analyzing their context in large data sets. Advantage. Capture semantic relationship. Example, complaint and grievance are contextually similar. Usage enable deep learning models to understand relationship between words for better classification. Those techniques allow machine learning models to derive meaningful patterns from raw unstructured complaint data, improving the efficiency of grievance redressal systems. Now, question number two, which is with reference to a life cycle of data science, complete the following table of all stages of life cycle. Basically, we have given a table and we have to complete it. So first, stage objective, key details or task to and tools or libraries. So first, define the problem. Clearly understand the problem and define the objectives. Identify the business problem. Set measurable goals. Define success metrics. None. Any specification. Next, data collection. Gather relevant data from the for the project. Identify data sources, collects the structured and unstructured data, validate data, Python, SQL, API, Scrappy. Next is data exploration and pre-processing, analyze and prepare raw data for analysis, handling missing values, remove duplicates, perform exploratory data analysis, and tools and libraries are Pandas, NumPy, Matplotlib, and Seaborn. Next is feature engineering, extracts meaningful features, improving model performance, And feature selection, feature transformation creates new derived features. And scikit-learn and feature tools are the tools and libraries. Model selection and building. Choose the best machine learning model. Select algorithm, train the model, optimize hyperparameters. Scikit-learn, TensorFlow, PyTorch. Now next is model deployment. Integrate the model into production system for real world use. Convert model to an API, deploy on a server or cloud. And the technology tools or libraries used are Flask, Fast API, Docker, AWS, GCP, Azure. And next is monitoring and maintenance. Ensure the model continues to perform effectively post deployment. Next is monitor model performance, update the model with new data, handle model drift. Prometheus, Grafana, MLflow, and communication and reporting communicates results to stakeholders effectively. Visualize results, generate reports, make actionable recommendations. Power BI, Tableau, Matplotlib, and Seaborn are the two required tools in library. Next is question number 3. Explain the role of text mining in automating grievance redressal system. List the key steps involved in pre-processing unstructured data. So, answer. Role of text mining in automatic grievance redressal system. So text mining involves extracting useful insights and pattern from textual data. In the context of grievance redressal system is helps by role of text mining in automating grievance redressal system. First is categorizing complaints. Automatically classifies complaints into predefined categories. Example, billing issues, service delays, saves time by uh, routing, routing complaints to a relevant department. Next point is our sentiment analysis. In this, we identify the emotional tone, that is positive, negative, or neutral of a complaint. Next is prioritizes urgent cases based on customer dissatisfaction. Now, next is keyword extraction, highlights critical keywords to summarize grievances quickly, helps in identifying trending issues. Next is sentiment analysis, analyzes recurring patterns in grievances to predict and address systematic issues. So next is automation of responses, generates automatic replies for common complaints using natural language processing, which is NLP, enhances customer experiences by providing instant feedback. Now, key step in pre-processing unstructured text data, text cleaning, remove unwanted character. This is example, punctuation, special symbols, and now normalize text. It is lowering all letters, lowercasing all letters. Tokenization, split text into individual words, phrases, or sentence for analysis. Now, next is stop word removal. Exclude common words, example, and the, then do not contribute to the meaning. Stemming and lemmatization, reduce words to their root or base form, example, running to run. Removing noise, eliminate unnecessary content like HTML text, URLs, and emojis. Next is handling missing values. Replace missing text with meaningful placeholders or remove incomplete entries. Vectorization, convert text into numerical representation using bag of words, TF-IDF, word embeddings. Now next is n-grams creation. Analyze combinations of consecutive words. Example, bigrams, trigrams for contextual understanding. Yes. Now question number 4. Explain the concept of linear regression, how the best line is determined. Write the algorithm for linear regression for given input data point, which is x, y. Now, concept of linear regression. So, linear regression is a statistical method used to model the relationship between dependent variable y and one or more independent variable, which is x. The goal is to find the best line that minimizes the error between the actual and predicted value of y. Equation of line is y is equal to mx plus c, where m is equal to slope of the line, c is equal to intercept value of y when x is equal to 0. Yeah. How the best line is determined. So the best line is determined by the minimizing the error measured using the mean squared error, which is MSE. MSE is equal to 1 by n, summation of n I is equal to 1 yi minus yi whole square, where yi actual value, yi predicted value mx plus c, and n is number of data points. The optimal values of m, slope, and c intercept are calculated using gradient descent or ordinary least squares. Algorithm for linear regression input. Data set x is equal to x1, x2 to xn, y is equal to y1, y2 to yn. Outputs slope m and intercept c. Yes. So firstly, we initialize parameters. So steps involved in it. First, we initialize parameter, that is set m is equal to 0, c is equal to 0. Choose the learning rate, which is alpha, and number of iterations. Calculate predicted values. Y is equal to mxi plus c. Next is compute gradients, that is partial derivative of loss function mc with respect to m and c. dl by dm is equal to minus 2 by n, summation of I is equal to 1 to n, xi yi minus yi. And dl by dc is equal to minus 2 by n, summation of I is equal to 1 to n yi minus yn. So fourth step is update parameters, update m and c using gradient descent. M is equal to m minus alpha dot del L by del M, and C is equal to C minus alpha dot del L by del C. Now, fifth step is repeat perform step 2 to 4 for a specified number of iteration or until the loss convergence. Next step is return final parameters, that is M and C are after optimization. Yeah, example calculation using ordinary least square. The slope m and intercept c can also be calculated directly using formula. M is equal to n summation of xi yi minus summation xi dot summation yi upon n dot summation of xi square is equal to summation of xi whole square upon c, and the formula of c is summation of y minus m summation of x upon n. This approach avoids iterative computation and directly computes the baseline. Now, question number 5, which is write an algorithm to create two clusters for the data set from the data set 2, 4, 10, 12, 3, 20, 30, 11, 25. Write the output of each round. Yeah, so answer algorithm to create two clusters using k-mean clustering input. Data set is 2, 4, 10, 12, 3, 20, 30, 11, 25. Number of clusters, which is k is equal to 2. Initial centroids, randomly chosen points on the dataset outputs, final clusters and their centroids. Next, so firstly steps. First we initialize. Choose two initial centroids randomly from the dataset. For example, let the centroids with C1 is equal to 2 and C2 is equal to 20. Assigns points to clusters. Calculate the distance of each point from both centroids. First we calculate the distance of each point from both the centroids. Assign each point to the nearest centroids. Next step is update centroids for each cluster, calculates the new centroid as a mean of all points in that cluster. Now we repeat steps 2 and 3 until the centroids no longer change or change in a minimal convergence. Next step is output final clusters and their centroids. So here we start first iteration, assigns points to cluster data points here and distance to C1 which is 2 and distance to C2 which is 20 and cluster. Which cluster it is going to be, inside going to be. So 2. So distance is 0 with C1 and distance with C2 is 18. So it is closest to C1, so cluster is cluster 1. Now 4. Now also distance is closer to C1, so cluster 1. Then 10 also cluster 1. Then 12. As you can see here, the distance from C1 is 10, but the distance from C2 is 8, which is lesser. So it going in inside the cluster 2. 20 is going to cluster 2, 30 is going to cluster 2, 11 is going to cluster 2, and 25 is going to cluster 2. Clusters after iteration 1. Cluster 1, which is 2, 4, 10, 3, and cluster 2 is 12, 20, 30, 11, 25. New centroids are C1 is equal to 2 plus 4 plus 10 plus 3 by 4 is equal to 4.75, C2 is equal to 12 plus 20 plus 30 plus 11 plus 25 upon 5 is equal to 19.6. Now, iteration 2, assign points to cluster. So distance data point now distance to C1 is 4.75 and distance to C2 is 19.6, which we determined earlier. And now clusters. So we repeat the same process, and clusters after iteration 2 is cluster 1 is equal to 2, 4, 10, 3, 11. Cluster 2 is 12, 20, 30, 25. New centroids are C1 is equal to 6.0 and C2 is equal to 21.75. Now iteration 3, then C1 becomes 6.0 and C2 becomes 21.75. Now the we first see that final clusters after convergence are cluster 1, which is 2, 4, 10, 12, 3, 11. Center C1 is equal to 7.0. Cluster 2, 20, 30, 25. Center C2 is equal to 25.0. Now final output cluster 1, 2, 4, 10, 12, 11, 3, 11. Cluster 2, 20, 30, 25. So now question number 6. Explain the key difference between K-mean clustering and hierarchical clustering algorithms. What are the advantage of hierarchical clustering over K-mean when visualizing clustered relationships? So key differences between K-mean and hierarchical clustering are aspect. So firstly, we will see in the aspect K-mean clustering and hierarchical clustering. So firstly, algorithm type. So partitioning algorithm divides data into K cluster. It is actually K. By mistake, becomes triple K. So divides data into K clusters and algorithm bottom up or division top down clustering. Next is number of clusters requiring predefined number of clusters, which is K, and does not require the number of clusters to be predefined. Cluster formation iteratively updates centroids to form clusters. Clusters are formed by, in hierarchical clusters are formed by merging or splitting based on distance measures. Output representation outputs the final cluster directly, but in hierarchical clustering produces a dendrogram, which is tree-like structure showing cluster relationships. Scalability, efficient for large data sets, commute and in hierarchical clustering, it is computationally expensive for large data sets. Now, shapes of clusters work best with spherical cluster, but can identify cluster of various shapes. Sensitivity to noise or outliers. Sensitive to outliers may distort cluster centroids, but less sensitive as cluster are merged based on distances. Now, advantage of hierarchical clustering over K-means. Firstly, dendrogram from visualization. A dendrogram visually represents the hierarchy of clusters. Now, provides a clear picture of how clusters are nested and related, and allow user to decide the number of clusters by cutting the dendrogram at the desired level. Now, next is no need to predefined K. That unlike K means hierarchical clustering does not require prior knowledge of the number of clusters. Now, next is flexible cluster shapes. Handle non-spherical clusters more efficiently than K-means. And next is hierarchical relationships. Display the full hierarchy of clusters useful for understanding nested groupings in data. Now, question number 7, which is classify loan applications by assigning applicants to one of the three risk classes using entropy, information gain, or Gini index. This is the equation for above table. So the table is this is income we given high, low, medium, and martial status N, Y, Y, N, Y. Gender is male, female. Property Y, N. If he has, then yes. If he don't have, then no. Credit risk ABAC and loan class CABC. Now, next, step 1, calculate the overall entropy or Gini index for dataset. Class distribution, loan class. Count the number of records in each loan classes. Class A2, class B2, and class 3C. Total rounds 7. Now, entropy formula is H is equal to minus summation of I is equal to 1 to N Pi dot log to Pi, where Pi is the proportion of records in class I. H of s is equal to minus 2 by 7 log 2 2 by 7 plus 2 by 7 log 2 2 by 7 plus 3 by 7 log 2 3 by 7. Now, clustering. Calculating h of s is equal to minus 2 0.286 minus 1.807 plus 2 0.286 minus 1.807 plus 0.429 minus 1.222. Now, h of s is equal to 1.53. Now, Gini index formula with Gini index formula, which is g of s is equal to 1 minus summation of I is equal to 1 to n pi square, and g of s is equal to 1 minus 2 by 7 whole square, 2 by 7 whole square, 3 by 7 whole square. Now calculating g of s, 1 minus 0.816 plus 0.816 plus 0.1837 is equal to 0.653. Now, step 2 is split the data on each attribute. Attribute income, high, medium, low. Split the data set into subset based on income values. For high incomes, record CCC, entropy H is equal to 0. All are in class C. For medium income records BB, entropy H is equal to 0. For low income records AA, entropy H is equal to 0. Weighted entropy H of S income is equal to 3 by 7.0, and all are 0, so answer will be 0. So weighted entropy will be 0. Now, information gain for income, Ig of S and income is equal to HS minus H of S of income is equal to 1.53 minus 0, which is 1.53. Guinea for income, G of S of income, so 3 by 7.0, which is 0. And Guinea gain is equal to G of S minus G of S of income is equal to 0.653 minus 0 is equal to 0.653. Now repeat the same steps for other attributes. Which is Marshall status, gender, property, and credit risk. Now, step 3, choose the best attribute for splitting. The attribute with highest information gain or IG or lowest gain index is chosen as root node for splitting. Now step 4, build the tree, recursively repeat the process to split each subset until all records are classified into single lone class A, B or C. Now result, after computing for all attributes, the attributes with highest information gain or lowest gain index is selected as root node. For this dataset, income likely has the highest information gain and is used for the first split. Final classification tree will assign loan classes A, B, C based on attribute split. Now, question number 8, analyze the impact of data preprocessing techniques. Example, stop word removal, stemming on model performance, assesses the system's performance using metrics such as precision, recall, and F1 score. Now, actually, this table is not here, it's by mistakenly here. Now, data preprocessing technique. Data preprocessing transforms raw data into format suitable for machine learning models. Some common techniques includes first stop word removal, that is removes common non-informative words. Example, the and is reduce the features space, focusing on the model on relevant words. Next, stemming, reduce words to their base or roots forms. Example, running to run, and helps combines different inflected forms of same word into single feature. Third is lowercasing, converts all text to lowercase to ensure uniformity. Example, cat and cat are treated as the same. Now, removing punctuation and number cleans the text by eliminating irrelevant characters. And next, TF-IDF vectorization converts text into numerical features, emphasizing unique terms in a document. Next is normalization, scales numerical features to uniform range to improve model performance. Now, next is impact on model performance, technique and impact. Stop word removal improves efficiency by removing noise, leading to better feature selection. Stemming or lemmatization enhances feature consistency by grouping similar terms, reducing overfitting. Lower casing prevents duplication of features due to case sensitivity. TF-IDF vectorization improves focus on relevant terms by reducing the words on common terms. Normalization ensures faster convergence of algorithms like SVM or gradient descent due to uniform feature scaling. Now, next is evaluating system performance. To evaluate the impact of pre-processing on model performance, we use metrics such as precision. First is precision, measures the proportion of true positives out of all predictive positives. Formula, precision is equal to TF by TP plus FP. Example, if the system predicts 10 positive classes and 8 are correct, then precision will be 0.8. Next matrix is recall, measures the proportion of true positives out of actual positives. Formula is recall is equal to TP by TP plus FN. An example, if there are 10 actual positives and the system identifies 8, recall 0.8. Next is F1 score, harmonic mean of precision and recall, balancing false positives and false negatives. Formula, F1 is equal to 2 dot precision dot recall by precision plus recall. Example, if precision is equal to 0.8 and recall is equal to 0.8, then F1 is equal to 0.8. It is basically a balance of precision and recall. Now, next is Example pre-processing impact. For the example pre-processing impact, without pre-processing, model precision 70%, recall 65%, and F1 score 67.5%. With pre-processing, stop word removal or stemming, model precision is 85%, recall is 80%, and F1 score is 82.5%. Conclusion: pre-processing techniques like stop word removal, stemming significantly improves model performance by focusing on meaningful features and reducing noise. Evaluating metrics like precision, recall, and F1 score confirms that improvements in real-world tasks like text classification. Now, question number 9. Consider a grievance redressal system for complaints from citizens. The following algorithm is to determine the most relevant sections of IPC that apply to the complaint using term frequency and TF-IDF weighing, calculate the required values and determine whether two complaint documents are similar. Step 1. Term frequency, which is TF. Definition: TF measures how frequently a term appears in a document compared to the total number of terms in a document. That is, TF is equal to T to TD is equal to frequency of term T in document D by total terms in document D. No, for term T6 in complaint D1, frequency of T6 is equal to 10. Total term in complaint D1 is equal to 40. So TF is equal to 10 by 40, which is 0.25. Now, step 2 is inverse document frequency, that is IDF. Definition: IDF measures how important a term is by calculating its rarity across documents. IDF of T is equal to log 10, log of 10, log base 10, and by DF of T, where N is equal to total number of documents and DF of T is equal to number of documents containing term T. For term T6, total documents N is equal to 4 documents containing T6 complaint D1, D2, and D3. DF of T6 is equal to 3. IDF T6 is equal to log base 10. 4 by 3 is equal to log base 10, 1.333, which is approximately 0.125. Now, next step is step 3, which is TF IDF. Definition is TF IDF combines TF and IDF to calculate the weight of a term in a specific document. Now, TF minus IDF is equal to TF of TD dot IDF of T. For term T6 in complaint D1, TF minus IDF T6 D1, 0.25.0.125 is equal to 0.03125. Now, step 4, which is cosine similarity. To determine whether two documents are similar, calculate the cosine similarity between their TF IDF vectors. Cosine similarity, summation of I is equal to 1 to n TF IDF minus Ti of T1 dot TF IDF Ti of D2 by under root of summation of TF minus IDF whole square to TF minus IDF whole square. Now, using the provided complaint matrix, calculate the TF IDF for all terms in two documents and then plug the values into the cosine similarity formula. Now, question number 9, which is consider the grievance redressal system for complaints using the table provided. Complaint D1, D2, D3, and D4. Offense term 15, 12, 5, 1. This is this, and we need to calculate term frequency for T6 and IDF for T6, TF IDF for T6 minus T1, and determine whether two complaint documents are similar using cosine similarity, which is seen before. So actually, this is the question is by mistakenly come here. So we've seen this already. Yeah. So this is the solution of our end semester paper. So thank you for watching this video and please like, share, and subscribe.